So we are at an interesting point in the development of video engineering and video equipment. Over the last few years, there have been advances of AV over IP protocols such as NDI, SDVoE, HD-Base-T, Dante Video, and so on and so forth, pick your poison. SMPTE, the Society of Motion Picture Television Engineers, recently ratified a standard called SMPTE ST2110, which is SMPTE ST2110. And this is a SMPTE ratified standard for AV over IP. Where this differs from the other protocols, all the other ones are proprietary signal formats that are owned and created by a specific company. Nothing wrong with that. But in order to be ratified by SMPTE, it does have to follow a few rules. It has to be available to anyone. There's no licensing fees for it. But more importantly, it does have to respect the rules of yesterday as we go towards the workflows of tomorrow. When we look at HD-SDI, for example, or 3G-SDI, I always ask people, how many gigabits per second does 3G-SDI require? 3. How many gigabits per second does 12G-SDI require? 12. ST2110 keeps that same nomenclature as we go towards an IP-based workflow. So as you're looking at cable types such as Cat6, which is 10 gigabits per second, we know we can do 3 discrete HD 3G signals down that line. Once you go towards what we call SFP28+, which is 25 gigabits per second, well, you can do 2 4Ks at 12G or multiple HDs. And then when we make the jump to QSFP, which is 100 gigabits per second, then you can really see how this gets very, very, very powerful. QSFP, for example, is one long fiber optic cable, one large fiber optic cable that carries 100 gigabits per second. You can now channel 9 or so 4K at 60 streams down this line. So unlike other protocols, which might have a bit depth of or data rate of 100 megabits per second or some arbitrary number, we've kept that same standard as we've gone. So the transition from SDI to 2110 is going to be very, very smooth. In fact, it's so smooth that there are throwdown converters from companies like AJA, Blackmagic, and so on and so forth that will allow you to take ST2110 and convert it to a copper standard and go vice versa. Now you might say to yourself, okay, well, AV over IP has existed. What makes ST2110 cool? By definition, ST2110 is multicast protocol, meaning once the network signal hits your switch or your network, it can go anywhere you want. The same with a matrix router is able to take any input to any output in any iteration at any time, and ST2110 network can do the same exact thing. Every single SFP cage or every signal will essentially have its own IP address or its own port. So utilizing a network interface, you can then route any destination or input or layer or multi-viewer anywhere you want on your network. That's where it starts to get really cool. So it makes you then ponder and wonder, what does a video ecosystem of the future look like? And we can safely assume that it's going to be a large network backbone with a lot of smaller throwdown network switches. By encapsulating content or signals into ST2110 or other protocols, it can then all be shared on the network. So at front of house, you can drop a network switch, then do an SFP28+ to HDMI converter, or ideally have a monitor that accepts 2110, and then they can have their multi-viewers in front of house. If you want to have a teleprompt feeding that same switch, not a problem, same idea. Once it hits the network, it can go anywhere. So I can have a switch at Media Server World, at LED World, at Audio World, at Dimmer Beach for lighting, and everything can be shared in real time across the network. And now that it's all networked as well, we're not even limited to one localized ecosystem. By utilizing port forwarding and whatnot, we can start putting this across the cloud, across the World Wide Web, and we can now be sharing uncompressed signals in real time across the globe. So ST2110 is, of course, just one particular signal type, but it really is opening up the world of future possibilities with networking, utilizing AV and IP homogeneously together.